Hi everyone. The next couple of videos are meant to walk you along the process of how to use Grasshopper, and in this case we're going to use it as a fabrication tool. Much like we've been using the 3D printers and the CNC routers as physical tools, here we're using a software as a tool to help kind of expedite some of the fabrication process. What we're going to do is start by using this as kind of a generic surface. We're going to kind of pretend that we want to make contour map out of this, something like a laser cut model. And we're going to kind of first do it in Rhino, and we did this several weeks back, but I want to refresh you. And we're going to do a similar task, but do it in Grasshopper. And just so you're all familiar, Grasshopper is a parametric modeling software, meaning first off, it's a plugin or an add-on, so it resides inside of Rhino. And it needs Rhino to operate. You can't run Grasshopper by itself. It needs to be within the Rhino environment. And parametric modeler simply means that you have a series of variables or parameters that you're adjusting, and as you make adjustments to that, you'll see the updates kind of downstream. And the most common example I like to give for this is something along the lines of Microsoft Excel, where if you use Excel and in column A you have the value of 5, in column B you have the value of 10, and in column C you may say columns A times B. As you adjust either that value of 5 or 10, the resulting value in C would automatically update depending on the new formula. And that's kind of what we're doing here, but we're doing it to control geometry and other types of data. So what we're going to do, we're going to start by modeling, contouring this again, doing a refresher within Rhino. And then we're going to do a quick little what is Grasshopper, and then we're going to move on to a couple other videos that then walk you through actually contouring this within the Grasshopper environment. You're going to need this surface to start with, and you can do that by simply going to the Carmen site, clicking Assignments over here on the left, going to the Assignment04 tab, and downloading this Rhino surface that exists. Once you have that, go ahead and open it, and you can bring it into the Rhino environment. Now, I'm going to go fairly fast through this video with the notion that you can stop it and start it, resume it as you need to kind of keep up with pace. So here's our surface, and if you remember, the contour command in Rhino is pretty simple. All you do is you type in contour in the command line, and then ask for an object to contour. Now, before I even like to get into the contour, I set up a bounding box because one of the first things it's going to do is ask for a vertical edge. So sometimes what I'll do is I'll select the object and type in bounding box, hit enter, and then it gives me an object or a box that exactly consumes it. Then I like to duplicate one of the vertical edges, so I type in dupe edge, hit enter, select one of the vertical edges, and there I have a duplicate edge, and I delete out my bounding box. That gives me the vertical line that I could use. Now this happens to work out pretty well because I do have verticals on the edges, but sometimes you don't necessarily have those. So I like to make this vertical edge for the contour command. So if we go back and type in contour again, it asks for an object to contour. You hit enter. Then it asks for a base plane or a base point to contour about. So I'm going to click in this lower corner beneath on the lower edge of my vertical line I made. Then it's asking for a direction perpendicular, and that's why having some sort of a vertical edge or vertical line is important. So you can select a perpendicular axis to which you want to generate the contour. So since I want XY contours, I want to select a vertical z-axis here to generate the contours. I'm going to click there. Next question asks is, what is the distance between the contours? And because I have this scaled down to 12 inches by 12 inch, I would set this to something similar to my material thickness, which might be 1/16 of an inch. Hit enter, and there it goes ahead and contours all those. Now I'm just going to move these off to the side for now since they're already selected. Just go ahead and drag them over. And those are all my contours for each of the layers. Now, one thing that's important to notice is that as I select on some of these edges, they are individual lines. We could go ahead and simply select all these and type in join. And any objects that are fully closed will then be joined as closed polylines, and that should be all of them. There should be no actual open objects that exist. And you'll see a whole lot of them. They're just a whole bunch of squares on the lower portion here. So we're going to do this, but the nice thing now is that if we come back here and say, all right, we don't want to use 16th inch material, instead we want to use 1/8 inch, or we want to use 32nd inch, we can quickly update that and lay that back out and label all that. From here, what we still have to do is we have to label all these layers. We have to go ahead and lay them all out on the XY plane, so that way we can nest them inside of our chipboard, our 24 by 36 or 32 by 18, whatever it is for the laser cutter, and lay those all out. Here, we're going to use the Grasshopper definition to do that for us. So I'm going to go ahead and just move this kind of out of our way so it's not in the way. Now, before I get into the whole how to do this, we got to talk a little bit about what Grasshopper is. So you'll notice that when you go ahead and make any sort of an object, and for this we're going to make a simple circle. If I click and hold on the circle, there's a lot of different ways to make a circle, but I'm going to go ahead and select this one in the upper left corner, which is just a circle center and a radius. When I click on there, the first thing it asks me is the location of the center point of the circle. I'm going to go ahead and click anywhere on the construction plane here. The second thing is it asks for an actual diameter, or we could adjust this to be radius. Oops, sorry, my Alexa in the background is turned on. So I can go ahead and click anywhere I want, and I can manually select the actual radius, or I can click a distance in the upper left. So what I can do is I'm going to click on the plane there, and now I made a circle. Now this circle is considered a CNR, center, normal, and radius, meaning that I dictated where the center point was, the axis or the plane that it was on, the axis it's perpendicular to or normal to, and the radius itself. So what I can do is go ahead and do something similar in Grasshopper. To do that in Grasshopper, what I'm going to do is type in Grasshopper in the command line to actually launch the program. Now I've already launched it, and I'm going to go ahead and dock it over here on the right hand portion of my screen. So this is how I like to have my screen set up. This is the Grasshopper environment over here. It sits on top of my Rhino environment over here on the left. This way I can go ahead and see what I'm doing and kind of work my way through it. The first thing I want to do is I want to go ahead and start by working my way through some of these tabs. These tabs are broken into types of geometries or operations that you're trying to execute. So you could do the basic is the parameters, which are kind of input information. Math operations, which you have simple additions and multiplications, as well as doing more complex functions and things along that lines. Sets, which deal with how do you deal with the data itself. Vectors, curves, surfaces, mesh, and intersections here. There's also a transform. We'll use this one once. There's often other ones depending upon what's installed in your computer. And if for whatever reason you can't get Grasshopper to install or to launch, try a different computer. But every computer should have it, and you'll have a few extra tabs depending on what the school has installed in there. We'll all have these first several, and that's what we're going to be working with anyway. So to do a circle in Grasshopper, the way that it works is you work in this environment here, and these are just old files I have. As soon as I go ahead and start a brand new file here, these are going to disappear. This is the canvas. And the only kind of important rule with the canvas is we always work kind of left to right. So what I want to do is I want to generate a circle. So I'm going to go to my circle tab up here. And consider one of the primitives. You'll see here in the middle we have a bunch of different circles. The one I'm fascinated with or interested in is the circle CNR. That's the same circle that we generate over here on the left, which is the center, the normal, and the radius. So we're going to click on there and launch and click in my canvas. And this is what a component is, and this is what a component looks like. It looks like a little bit of a battery, some people say. You'll have inputs that are on the left and outputs on the right here. And we're always going to work from left to right, kind of like we're writing a sentence. So the inputs here are, if I hover over it, the center point of where I want the circle to be, the normal, in this case the plane that we generate the circle on, and the radius. You'll see here that the radius already has a value of 1 stored in it. You'll see here that the plane is already set for 0, 0, 1, meaning the 1 is in the z-axis, so it's going to lay down on the xy. If that said 0, 1, 0, it would be on the xz axis, and so on. The 1 is the direction that is normal to or perpendicular to. So in this case, the 1 is in the z, meaning it's on the xy plane. The only thing that is empty right now is the center point, and that's why this component is orange. There's a couple different colors components can be. Orange simply means nothing is happening. Green means it's selected. Gray means everything's working. And red means you have an issue or an error. Here, nothing is happening because we haven't actually given it a center point. We can give it a center point in a couple different ways. The easiest way is to reference something that exists in Rhino. So back over on the Rhino screen, I'm going to go ahead and click on my point component. I'm going to drop a point in there anywhere in space. So there's my point in Rhino. And now I need to bring this Rhino geometry into the Grasshopper environment. To do that, we use a container, go to parameters. These are all input things, things like number sliders and panels. But in this case, we're inputting a geometry. And we want to use the point container, so the point geometry. Click on that. And because I'm using this as an input, I'm going to keep it on the left-hand side. I'm going to go ahead and it's orange also, meaning there's no data in there. I need to reference this point in Rhino. So what I'm going to do is I'm going to right click, go to set one point, and then the Grasshopper screen kind of minimizes. The Rhino command says select a point to reference. I'm going to click on that point in Rhino, and there it goes. Now I get a red X over the top of the point. That actually references the red X is actually the Grasshopper preview for it. Now it's green because I have it selected. And that point still exists in Rhino, so I can go ahead and move it around or do whatever I want with it still. I'm going to use that now as the center point. So I'm going to go ahead and wire that in. And you'll see now we've generated a circle. It's this red circle that's tethered to that control point as the center point. It's on the XY plane, and it has a radius of 1. Now, a couple things that are making these variables. These are your 3 parameters or your 3 variables. Next thing I want to do is I'm going to make the radius adjustable. So I can do that again as an input under the parameters tab. I'm going to go underneath the input tab and use a panel tool. A panel kind of looks like a sticky note, and it's what we use to actually type in numerical data, things along that line. So what I'm going to do is I'm going to double click, delete out the old text, and just type in the value of 2. Notice I'm not hitting enter or spacebar or anything. The cursor is blinking after the 2. Okay, you have to be sure you do not hit enter or spacebar after it. Now I'm going to go ahead and click off of it, and I'm going to go ahead and just wire from the output to the input. And you'll now notice that the circle got larger. If I go in here and change the value to say 5, you'll see it gets even larger and so forth. Okay, so this value now is controlling the radius of the circle. Notice that the point is still tethered to our Rhino geometry. So if I go ahead and select this Rhino point and move that point around, you'll see that the circle now moves with it because all these things are tethered. This is the whole point of having parametric modeling, is that as you move some of the things that are the inputs, the resulting output, in this case the circle, is moving with it. Now we've given it a value of 5, but this is a very stagnant way to be able to type in a value. The other way we do it a lot of times is using this number slider component. So if you go to parameters, input, and number slider, you can drop that in. And if I wire this in, you'll see it automatically unwires the previous value. Now if I go ahead and use this radius slider, as it's being called, I can kind of dynamically adjust it. Okay? And that radius slider will control the actual radius of the circle itself. Now it's only set up for a value of 0 to 1 as the maximum. You can adjust that by simply double clicking on the word radius, and you'll get this dialog box. Here in the middle, we can set the minimum, the maximum, and or the range of the slider. The minimum, we never want to circle less than or add 0, because a 0 is not a valuable circle, or a valid circle, I should say. So I'm going to set the minimum to 0.01. I'm going to set the maximum now to 100. And by default, then the range becomes 99.99. Hit OK. And now my slider is far more, has much more range to it. So this is the kind of basics of what Grasshopper can do for us. This is how we can, I showed you kind of how to do the contour operation in Rhino, how to make a basic circle, how we would do that in Rhino, and the kind of equivalent of how we would do that here in the Grasshopper environment. For the next couple videos, we're going to focus back on this actual object. We're going to start writing a definition and allowing ourselves to make a dynamic version of this contour map over here on the left. Come on back for that, and again, you want to make sure you're going to have this file available for you for this next video.